Hey class, you know what time it is. There's a quiz tomorrow, so that means videos go up tonight. And I gotta remind you, period 8 knows this. Period 1, I don't know, I wonder if y'all forgot. But lesson 10, that's on your quiz, in case you forgot. So lesson 11 was verifying identities. Lesson 12 was solving equations. And they kind of got all of our attention. But lesson 10, that stuff's on the quiz too, so we better make sure we got it. So, here on page 1, this is an example that we for sure did in class. And on page, the next bit, these are some examples you were supposed to try on your own. And then we got to the classwork. And then finally we get to a set of problems here. I'd like to think I told you to do all 6 of these because these don't take very long. So I'm telling you that now. I'd like you to do all 6 of these. And I'll do some of these right now for you, at least give you a heads up on how they look. Ooh, that's too big. But we're looking at these. That's better. Number 1, you look at it and you should be recognizing that is almost the form of the double angle cosine. Double angle cosine identity. The cosine of 2 theta is cosine squared theta minus sine squared theta. So there's 2 issues in number 1. There's a 2 there, that shouldn't be there, but we'll just factor that out. But then we also need to switch the order. So for number 1, I'd start by factoring out the 2. Then I kind of reminded myself of a good old trick. I was watching one of my old videos to see if I could just post that video. And I don't know, kind of I can. I've been telling you guys that A minus B is just equal to B minus A. And I'm just telling you, just do it and put a negative out in front of it. To maybe make that make a little more sense, I was reminded that one way to think about this is that essentially what you're doing is factoring out a negative. So instead of 2, let's have negative 2. And that'll change the sign of these. So you'll get negative sine squared 105. And this will change to a plus cosine squared 105. And now that you've got a plus, you may go ahead and just switch the order of these terms, remembering that the sine squared is now the negative. So you'll go negative 2. Cosine comes to the front now and is positive. Sine goes to the backs now. And it's negative. So instead of adding, it goes to subtraction. So that's maybe a better justification, a better way to sort of latch on to why this works the way it works. But if you think about that, where I'm factoring out a negative, so a negative suddenly appears in front, the signs change, then I can switch the order. That might make more sense algebraically to many of you, and so maybe that's helpful. So anyway, now to finish this off. For these problems, you have to do 2 things. We condense and evaluate. So condense means this will be negative 2, and it'll be times the cosine of the 105 doubled, so 210. And I don't want those parentheses. Okay. So I'm going to want 2 answers from you. I'm going to want this expression that just says the answer is whatever negative 2 times the cosine of 210 is, but then I do want you to actually evaluate this thing too. So negative 2, cosine 210, 30, cosine negative root 3 over 2. And we're multiplying here. So the 2's cancel, the negatives cancel, we get positive root 3. So those are the 2 answers I'd be looking for if I gave you this expression. We could try a few more of these, although, maybe we did these in class. Maybe you guys feel really comfortable. Maybe that's why. Maybe that's why you weren't asking questions about it. So let's do another, and then another, and another. So number 2 is a little different, so we'll do 2. So if I see sine 105 and cosine 105, then that's looking kind of like the double angle identity for sine. It's just missing a factor of 2. So we'll use that trick where we multiply by 2, and we also multiply by 1/2. And so now we've got the double angle identity for sine. It's just going to have this coefficient of 1/2 on it. And then we evaluate. So there's the expression I would be looking for. Then to evaluate it, you go 1/2 times 210 is going to be -1/2. So -1/4. I think that's it for 2. And then 3 I wouldn't bother doing. Because 3 is almost literally identical. You know what? We better do 3. You factor out a 2. And then you're left with sine squared of 105 plus cosine squared 105. And so as long as these angle measures are the same, this is sine squared plus cosine squared. That's a 1, no matter what these angles are, as long as they're the same angle. So this is a 2 times a 1. That's just 2. So yeah, that's 3. We can do 4 now. So 4 is giving you 2 sine squared 105. And we know that 1 minus 2 sine squared 105 would be an identity for us. But if I do that, then what have I actually done? It looks to me like I've changed the sign of this. I've multiplied by -1, and then I'm essentially adding 1 on. I just don't like the feel of this. This feels weird. So the way I usually approach this is, I know I want a subtraction sign and a 1, so I just imagine subtracting 1. And I know that's in the wrong order, but I can fix it in a second. And also when you subtract 1, you have to add 1 back on to keep that balance. But anyway, I'm going to do that, and now I'm focused on this part. And let's do the same thing where we just switch the order of terms here. We know that this will become 1 minus 2 sine squared 105, as long as we put a negative on it and add 1 to the outside. So in terms of giving my answer as an expression, it looks like I'm getting the opposite of this thing, which is double angle cosine. So the 105 doubles to 210, and I'm adding 1 on the end. So a couple changes here. It's not just the cosine of 210, it's the opposite of the cosine of 210 with a +1. But we can evaluate this. Cosine of 210, we already said, was -√3/2. And then we're adding 1 to that. So this will be +√3/2 plus 2/2, which is 2 plus √3/2. Alright, that's 4. Well, I'm just going to do them all. They're quick. Alright, so for 5, looking at 5, we got 6 sine cosine. Alright, and again, I can recognize that if this was just 2 sine 105 times cosine 105, yikes. If there was a 2 there instead of a 6, then I could apply the double angle sine identity, and then it hits me. 6 is 3 times 2. So I can rewrite 6 as 3 times 2, and then I can use the factor of 2 to form my identity, keep my factor of 3 as a coefficient. So this will become sine of the 105 doubled, so 210. But again, that's it. This would be the expression I expect you to give me. then you evaluate it. So I'm doing 3 times sine of 210, that's negative a half. So the final outcome is negative 3/2. That's that. Now we can do 6. So looking at 6, it's really similar to our double angle identity for tangent, which we have not used at all. So just for a hot second, I'm going to remind you where it comes from and how you can remember it, although maybe y'all don't know anyway. The way I'm about to try to teach you is, you'd have to actually remember what the tangent of alpha plus beta is. Maybe you forget, but that's tangent of alpha in the numerator plus tangent of beta in the numerator, and that's all over 1 minus tangent of alpha times tangent of beta. So if you knew that, then what you do for this is you think of tangent of 2 theta as the tangent of theta plus theta, meaning that over here both alpha and beta are both theta, and so in the numerator you've got tan theta plus tan theta. That makes 2 tan thetas, and so that's the first term of our expression here. It'll be 2 tan thetas in the numerator. Then in the denominator, same kind of deal. We've got a theta here and a theta here. So we get 1 minus tan squared theta. But this is the rule I'd expect you to have memorized. And anyway, so now looking at problem number 6, we can see that the only thing missing from here is a factor of 2 in the numerator. And again, I can bring in a factor of 2 by just multiplying by 2 and then canceling that 2 out by also multiplying by a half. So if I do that, then the 2 actually wraps itself into the rest of this identity, and we would end up getting 1/2 as a coefficient on the tangent of that angle doubled. And then again, that's the expression. Now you just evaluate it. 1/2 tangent of 210, that's a 30-degree reference angle, but it's in quadrant 3, but tangent's positive in quadrant 3, so it's just root 3 over 3, which is root 3 over 6. And that's it. That's lesson 10 reviewed. The other 2 lessons are much more substantial, so let's just get this here video published. Y'all can be watching it if you need to. Talk to you again soon.